Hello friends. So in this video today we are going to talk about three memory analyzing tools, which is basic tools that comes with a JDK pack itself. Okay, these tools names are JConsole, JVisualVm and JMC. There is a chance that in different version of JDK all of these are not present, but I have found in JDK 1.8 or we call JDK 8 all of these tools are available. JConsole, JMC is Java Management Console, and JVisualVm. All of these three tools are visual tool, means UI tools. There is also a command line tool we call jhat that is also used to analyze the heap dump. We will talk about that also, but let's just see uh, an overview of these tools. These tools plays a different role, plays a different, like JConsole does not have uh, a lot to do. It is mainly we can use it to manually monitor the application. We cannot use this to create the heap dump like that. Okay, so let's just I have an application running on my machine. Okay, so let's start the JConsole, and as soon as we start the UI tool, this JConsole, all of that running application is get identified itself by this tool, and we can choose which application we can connect to. So here this one tool, the JDK console itself, JConsole itself, and one is the application that is running on this machine. Okay, out of memory case, so we can connect to it. Just double click on that or click on connect button and we can connect it. So this gives a graph and chart to the memory. You can see there are different memories, like memories, heap uses, and different memories, you know mm, uh, generation. We can select whichever we want to analyze. Okay, and here are some little details about the application, the JVM, like GC time took 0.43 second. Okay, in the generation 1, in old generation of G1, uh, it does not have performed GC. Here is, when we click here, the graph is showing the heap and this one is showing non-heap. Okay, something about threads here, all of the running threads here we have, and the class, it gives a little bit about how many number of total classes and currently loaded classes. Okay, here the times, we can select, like in last 12 hour how many classes, or you can see the graph here, because we have selected 12 hours, so the graph is created for 12 hour. Let's create for 1 day or 12 hour. Okay, so this is how we can select the graph or monitor the class history. uh, we don't have here option to create a histogram. Okay, so that we can analyze which class is taking how much memory. Okay, so this is, here is a VM summary, like which Java garbage collector is being used. Okay, uh, the connection details, uptime, so something about the VM information. Okay, so here we see the VM argument. Just to tell you the information is that one information, We ran this application not just by something like uh, Java and the Java, I mean the class name. No, we have configured something here, in the VM argument, I mean in the command line argument, to make it enabled to be able to connect to uh, from the remote machine. Let's see, let's talk it here. So I'm going to show you the example. Right now I am connected locally. You saw that when I restarted this, when I started this JConsole, the local process was already identified. But just assume that this application is running on remote and we want to connect to it. Okay, the important thing is, see, we know that in the production or in the reality, we have to analyze the real application running on production, or something in like prod test environment or staging environment. Developer machine environment like dev environment is not going to give a real time statistics. Okay, so we need to connect to uh, remote machine. Okay, so how we can connect it? Because we have run it on by enabling some JMX and some port. So this is the command, this is the way to enable the JMX when starting a Java application. So let me try to connect to the that environment, that remote machine. Just assume that I'm running the application on remote. Okay, so at the time of running I have not used this port, this IP. I have used 192.168.1.34, and then we have to give the assigned port number. Okay, 65535. Okay, and then connect. See, so now you can feel happy, like, okay, I am now connected to my um, JVM, the application which I really need to monitor in the production. Okay, so this is about JConsole. We can monitor the application. Now let's move to uh, VisualVM, JVisualVM. Okay, so here also you can see, as soon as this UI tool gets started, our process is identified. Okay, this is the main entry class name. You can say what is this out of memory case is. So this is nothing but our main class name. Okay, and this is the process ID. So here what we can do, here we can monitor the application also. Okay, here also we can monitor the same thing, like CPU memory utilization, heap memory, classes, lot of things here we can do. um, Thread information, sampler also we have here. um, this is the same thing, the VM argument and the system property. But here what we can do, here we can perform heap dump, perform GC. Okay, so now if we want, we can create a thread dump or heap dump or application snapshot. So let's create a heap dump. Okay, so we have got a heap dump created here. Okay, we have got the heap dump created here. I think we have option to we have option to save. We have option to save. If we create heap dump here, again a heap dump is created. Okay, no worry. So from here we can get the heap dump. Remember one thing, what is the extension of heap dump? What is this? HPROF means heap profiling. Okay, the dump extension is heap profile, HProf. You can simply remember it, heap profiling, HProf. Okay, if we already have a heap, okay, I mean if we already have a if we already have a heap dump, we can load it from here. We can load. Okay, so I have some heap profiling, heap dump, where it is, not here. Let me, oh sorry, okay, memory analysis. We have to take heap profile. So let me get this one. Okay, so this was the heap profile I created from the command line. Okay, so we can use JVisualVm to analyze the heap dump as well as create the heap dump and thread dump also. Okay, the same thing we can create here, a thread dump. Okay, uh, we can also see the class histogram. Now here see that something. Okay, here is byte array. We can see it is going to tell number of instances. Okay, and the size of the memory these classes are taking. You can see bytes, everything comes into the bytes. String, we have lot of string, and it is saying, you can see, if you can properly see, 22%. How can I go back here? Okay, I can go back. 22% string is being used, and after that there is a custom class which I have created. This is user class. Okay, see this program. Okay, user, this is simply user class that I created. Here is that user class, and I am just using this user class in the while creating number of objects. Okay, n number of objects till the application is running. It will keep adding into the array list. Okay, so just to demonstrate the purpose, like how we can see which class is taking much of the memory. Okay, uh, instances, there are instances. We will not talk about that now. There is something called OQL. We will also talk about later. Okay, this is kind of a query language that we used to do in HQL, but this is the same way, accepting the query. Select what is select s from java.lang.string. I think it does not take semicolon. How we can execute this? Oh, see this, all of the too many. Please refine your query. Okay, so we need to refine it. We can give the size or something, or match pattern. There is a whole lot of idea of this OQL, object query language. We can talk about later, and this can be useful. It can be a little bit handy in terms of, identifying. Basically, we can perform this query on heap dump. Okay, we'll see that. We'll try something, an overview or separately on this in another video. Okay, so now let's go to another tool called what do we call JMC, Java Management Console. Okay, and one more thing I wanted to show you in the JVisualVm also. So we saw in the JConsole how we can create the sorry, here I think we already saw how to create. Okay, remember one thing in the let me stop this mission control. Okay, JMC is not my management console. JMC is called Java Mission Control. Sorry for that. Okay, JMC is called Java Mission Control. So in the JVisualVm, I wanted to tell, see, in the JConsole, when we were talking about JConsole, we got to understand, okay, uh, we have to monitor the application which is running on remote machine. Okay, so here also we, in the heap analyzer tool also, we need what? So first of all, what we need a heap dump, and we need the heap dump of a real application which is running on remote. So there are multiple ways of creating heap dump. We have some command line argument to pass, like, and in the case of out of memory it will generate the heap dump. But from this visual machine also, this visual VM also, we can create heap dump. Okay, like here we just this is our class, and we said that okay, we can create our thread dump or heap dump. Okay, you see this node, this is local node. Okay, and this is remote node. So here also right now we don't have, right now I don't have any remote machine connecting to my laptop, and any application I cannot show that. But there is an option, the same way we saw in JConsole. What we can do, 192.168.1.143 I need to give the port also of the running application. So you remember we ran the application with port 65535. Okay, is it creating? I'm not sure, but this is how we can, let's see this, what it's going to do. We have the application running. Okay, and application is running with 65535 and 192. Okay, it's not 134, it's 34. Oh, okay, let me remove this, or how I can. Okay, so let me how can I remove this? Okay, now add 192.168.1.34, 1.34 before host name already monitored. Oh, okay, okay. So this tool is smart enough to identify the machine is a local machine. So it is giving a message that this is a local host machine. Okay, this host already monitored as local. Okay, but you remember, you saw that process, how we can um, connect to that. Okay, connect to the JVM which is running on a remote machine. So what will happen? What will happen is that the same way it will show the process ID. I mean the process which is running, and we can create the heap dump same way. Okay. So this is the main important thing. As a developer, we have to analyze the heap. This is our responsibility to maintain the performance and find the problem in the application. So we need the heap dump, and we need the heap dump of real application, means production grade application. So this is how also we can get it if we have not started our application with that parameters, the parameter which called generate, I mean create a heap dump on out of memory, something like that. Okay, so this is about visual VM. Another thing is Java mission control. It's not management control. So Java mission control is kind of an extension of or the next level we can say um, for monitoring. Uh, this is basically mainly used for analyzing the JFR, Java flight recording. You can see uh, okay, so here we have so this is also identified the local running process which is out of memory case. We can double click it, or we can right click and we can say start. Here we have three options: start JMX console, start flight recording, control the JMX remote JMX agent. um, I think start this parameter flight recording is probably a commercial feature. So when you say start flight recording, it will give you an alert or whatever. You can choose the option. But for now, let's just see. We are just going to see an overview. So this is a more rich tool to analyze or to monitor the application and generate and read the flight recording. We will talk about Java flight recording in details also in some other video. But here we can see the dashboard, a nice dashboard of the heap, and here it's giving now 4 MB is being used and max is 8.38 MB. JVM CPU uses this much percentage. Live set and fragmentation. There are whole lot of, there is histogram data setting also. Okay. There are a lot of tabs here. This is the processor and this is the JVM memory. We have option to choose, you see, total versus used heap memory. You can see total memory is here, okay, and heap memory is here. If we remove this, it will come up, okay. Committed heap memory versus used heap memory versus max heap memory. Max heap memory is 2 GB. Okay. Ambient browser. Ambient browser we will talk later, not in this video. Trigger. Trigger also we will talk a little bit about this later. I also need to refresh this, go through it. System property, system information. Do we have class histogram here? Okay, here is also we have, or we can go up, scroll it down. Okay, a different mean of explaining the memory. You can see code heap non native method, code heap profiled native method. Native method means, I mean, sorry, not native method, I'm talking about code heap means the code which might be causing lot of memory consumption. Okay. Thread, this is the thread, and what we can see more, diagnosis command. These are the all those command that is present in JCMD. Here also, here we are not able to see all of this command uh, options, like you we are not able to see here gc dump. Okay, do we see here? I don't think we have gc dump, or we have gc. So heap info. Okay, so how to do this? If we want to see the gc heap info, we can select and create. We will get some message. Read this carefully because your application is running in production. So okay, this is giving a some information about the heap memory. Okay, but this is the main thing here, recording flights. Okay, flight recording and dump default recording. Okay, there are lot of way to create flight, yeah, record the jfr. Okay, we will see some. We'll create a separate video for talking in about jfr, but in this video, this is all about the three management tool means the memory analyzer tool. And this is not, you know, there are this is not final tool. There are multiple tools to analyze the memory, like, you know, eclipse, um, what we call eclipse memory analyzer tool. Let's see that. That is also I have running with, you see this, eclipse memory analyzer tool. This is also quite popular, and it gives lot of information. um, we will also see this here. Here you can identify, you know, even what is the size of your object, what is the retained size, and how much percentage of memory is taken by this application or which object. So, you know, friends, the important thing is that JVM memory analyzing is a deep topic, and as much as we learn about that, uh, uh, that is that would be good for our application. Means as much as knowledge we can acquire about uh, the memory, how the memory JVM internally works, what can cause the, see, there are three important things to analyze: memory leak, out of memory issue, and deadlock issue. So using this tool we can try to analyze our, where is the problem in code. See, basically always, most of the time, this is the problem in the code. Okay, we will talk more about this. I will also, I have to, I don't have a lot of knowledge about this, but I'm going through this topic, so will share the information as much as I learn, as much I can share. Okay, so yeah, thank you all about this video. Stay safe, take care, bye bye.